So let's begin, guys. First of all, thank you so much for joining our today's session. I think this is week 2, what we have for the cloud practitioner. We had a week 1. Last week, we understood around what's exactly the certification is all about, why people are more looking to do certification and all of the stuff. Hopefully, I assume that you guys would got a chance to go through the recording, what we have given on the Slack channel, as well as the presentation. And if not, please go through that and let's make the Slack channel more interactive. So if you have any questions, queries, and thoughts, we can go through that. Now in this session, at the end of the session or even offline on the Slack, I'll be happy to answer, but let's ensure that you get or pull out some time from your busy schedule to go through that. That will ensure that all the upcoming sessions will be more interactive for you guys. With that, let me go ahead and share my screen. Hopefully my screen is visible to everyone. I assume that's yes. Okay. Cool. So yeah, today we'll have two interesting topics and the core foundation. We'll keep certification aside. It's a core foundation thing when we talk about Amazon S3 and Amazon EC2. We understood about how different AWS, what different types of services provided by AWS, how exactly they segregate based on the business application. But the core two services, which is constant across each of these things, are Amazon S3 and Amazon EC2. That's exactly what we will be focusing on as of today. I'll quickly, I think I had a brief discussion about in the last session also. My name is Sanchit. I work as a lead architect at Quantify, as well as I'm an APN Ambassador based out of India region. I work closely with the different communities across India and rest of the world to contribute and take the community to the next level. Really appreciating all the efforts put by AWS Usergroup Bangladesh and Women in Big Data to give me this opportunity and platform to share my knowledge with you guys. With that, let me focus or jump on today's agenda. So this is going to be high level, 3 major topics, what we are going to talk about. First, recap of the last session, what we learned from the last session. Let's brush up a couple of quick slides around that. Then we'll talk about Amazon S3, followed by Amazon Compute services, which in specific in compute, there are many services. I'll talk about that when I go into that section. We will be highlighting about EC2, which is a core and foundational service which is required. With that, let's jump on to the recap of this last session. So in the last session, we clearly understood what exactly is cloud computing, why people are looking at cloud computing. We also understand these are the different benefits which are provided by the cloud computing, disaster mitigation, shared pool resource, on demand, pay as you go kind of a model, and elasticity. Along with that, we also understood the deployment model of it, like public cloud, hybrid, private cloud, and as well as a service model, like infrastructure as a service, platform as a service, and software as a service. So in nutshell, we cover up in detail what is exactly cloud computing, why people are moving towards cloud computing, deployment model, and service model, right? So that's a glimpse of, we spend like most of the time in the last session to understand about the introduction part of the cloud computing. Then we jumped into the introduction to AWS, being a part of the public cloud in the deployment side of it, where we understood how exactly geographically wise the entire global infrastructure of AWS is broken down into 3 different things, right? Region, availability zone, and within availability zones, you have different data centers, and then you have the different point of presence, which is more like a caching kind of stuff, right? So this is how the entire things was broken down into 3 stuff around it. And then we also understand like how exactly, as I was talking about in the beginning, that AWS has categorized or structured all of its different services into different requirements, starting from infrastructure to foundation services to platform services and application, right? Again, there are many more services outside to it, like machine learning and all those kinds of stuff. But how exactly they've been categorizing it and creating the entire cluster or entire catalog around that particular domain. So that's what we learned in the last session, if I quickly talk about it. And today we will be focusing around Amazon S3. So before we start around Amazon S3, right? In simple, Amazon S3, you can assume it's like how you have your hard disk, a disk, right? If you have a disk or you have a pen drive or Google Drive. a kind of a storage where you can store anything. You can store your document, you can store PDF, images, video, or zip file, exe file, any of your programs, anything, or even your backup of your laptop, right? You can store any sorts of thing, any sorts of object. Similarly, the kind of storage, object-based storage in Amazon is called as S3, right? Simple storage service, S3. So in case of S3, right, S3 is one of the foundational service which has been, or if you pick up any of the AWS services, whether you talk about from a DevOps perspective, you talk about data analytics perspective, you talk about machine learning, or you talk about media services, right? Or security. Each and every service relies on S3 as a form of a backend or a backbone, which can be in any form to process their logs, to act as a storage in the background, right? Or to store any of the stuff, right? Any of the outcomes which get generated, intermediate stage. S3 is a core and a foundation of each and every services which has been available on the AWS console. Why? Let's understand it, right? Why S3 is so peculiar and so famous, not just in the external market, but within the AWS also. First, S3 is very scalable, right? Now, if you talk about pen drive or your hard disk, it can provide you maximum, what is the limit? Either if you have a hard disk of 1 terabyte, it can only give you up to 1 terabyte. Now, if you want to extend above and beyond, you have to purchase a new one, or you have to extend it, right? You have to get 2 more pen drives, or you have to extend that capability. Same is in S3, but S3, as I mentioned last time also, in case of cloud, you don't have to worry. It's a pay as you go and elasticity. Those are the 2 thumb rule of the cloud. That's why, let's say today you need like 5 GB, tomorrow you need 50 GB, let's say third day you need 500 GB or 5 terabytes. S3 scales very seamlessly in fraction of seconds, and it's very unlimited. You can easily store up to 5 terabyte of single object. Any single object which is of 5 terabytes, you can store it. So similarly, you can store like 1,000, 10,000, 5 terabytes of object. It's very unlimited. And the pricing is also, you don't have to pay like upfront. Whatever you store, how much you store, gets pay as you go kind of a model. So let's say you store like 1 GB throughout like 29 days, and then you store, let's say 10 GB on 30th day, the billing will be the prorated of everything of what you have consumed. It's not going to be, let's say 10 GB for 30 days. It's exactly what you have consumed for entire 30 days. That's exactly what you will get, which is like 1 GB for 29 days and 11 GB for 30th day. So that's how you will get the pricing, which is pay as you go kind of a model. So remember 2 things. Because of unlimited storage, the way it can scale in terms of the storage and accessibility. Third is pay as you go. Because of these 3 things, S3 is the backbone, and it's been widely used across all the different services, across any of the business use case or application you pick up. If you go to any of the AWS blogs or any solution, you will for sure see that there is an S3 around it. Even if there are APIs, you will see there is an S3 where the API output get persisted, or API, the input is given via S3. That's one. Now let's understand in detail how exactly S3 has been structured. So in case of S3, there are very 2 important things. What you have to remember: bucket and object. Bucket is simple like your folder. Directory. In Linux, we call it as a directory. In Windows, we call it as a folder, right? So bucket is nothing but a logical partition, which is like your folder kind of a thing, or a directory. An object is simple as a file. Like what you talk about, like a file. And a file can be anything. File can be an PNG, JPEG image, a PDF, a zip file, anything, right? It's called as a file. And in file, generally we refer in as a file. In case of S3, it is referred as an object. So do remember 2 things. In case of S3, you have bucket, which is like a folder or directory, and you have an object, which is like a file, exactly, right? Now within a bucket is your main parent folder, what you can think about, right? Like in simple, how you have in a hard disk, you have C drive, you have D drive, and you have E drive. Now that C, D, and E is nothing but as a bucket. Now within the C also, you can have 10,000 different folders, like folder 1, within folder 1, folder 2, within folder 2, folder 3. That kind of tree structure or hierarchy you can have. Similarly, you can have multiple nested folders. In case of S3 itself, there is no limit around it, but technically you can map that drive kind of a thing here with the bucket. And by default, any file or any bucket you create or any file which you store in S3 is default as private. That means it can be only accessed by the people whom you give the permission. So let's say I don't have permission to your AWS account, then doesn't mean I will able to access it unless and until you make a public or give me the permission. So that's a by default nature around it. And along with that, you can also do like in S3, whenever there is a new file upload or someone deletes a file or someone updates a file, you can orchestrate a different workflow also to receive multiple things like notification or to orchestrate an entire business application. Or you also define that, okay, someone uploaded a file or someone changed the file, right? So those kinds of different things, what you can do when it comes to the S3, when it comes to the basically when it comes to event notification. So you're not only getting the unlimited storage and scaling, you're not getting as a pay as you go kind of a model, but also in a very simple way, how we really work in and out, along with advanced capability of tracking what's all the activities in form of action on S3. So that's about quick, I would say, what is S3 and an overview around it. Moving towards the next, the naming convention. It's very important that you name it properly, right? Now, for simple of it, now someone, if you would have format your own laptop, you could have already understand. You never, in Windows, you never can create a drive which is A and B. It always starts from C onwards, and then you can have any alphabet, you can have up to Z, right? Similarly, in case of S3 also, there are certain guidance are there. There are certain standards you need to follow when it comes to the naming for the bucket. First important point and most important point is buckets are defined regionally, which means, let's say if I want to create a bucket, I will create it within the Mumbai region or within the US region. So bucket I will define within a particular region, but the naming convention of the bucket, whatever the name I give on the bucket, needs to be globally unique. So it cannot be that, okay, I can just create a bucket which is demo in Mumbai when there is a demo bucket already exists, let's say in US by someone else, right? And again, it's not just globally unique for your account, it's globally unique across all the accounts. So whatever AWS different users are there, which is like around in billions, it has to be unique across all those different billion users and their accounts. So it has to be globally unique. Remember that, that's a very basic and fundamental thing. The second point is a naming convention. You cannot have uppercase or underscore. It has to be always lowercase. Like you can have hyphen, but it always has to be lowercase, no uppercase, no underscore. And naming case can be like, as I mentioned, no uppercase, no underscore. It needs to be minimum of 3 to 63 characters. IP addresses is not allowed. And again, it should always start with a lowercase letter or a number. You cannot start with a special character like dot or hyphen or those kinds of stuff. It should always start with alphanumeric, either any character or a number. And again, that also in a lowercase. You cannot have uppercase. Not as a first, in an entire bucket name, you cannot have an uppercase. So those are the basic things, how exactly you can create the bucket or name when it comes to the naming of the bucket. Now let's do a deep dive how exactly the object works. So if you remember, recall the previous slide of overview, as I mentioned, there is no limit of defining the folders within a bucket or the kind of prefix, right? Similarly, here exactly what is mentioned, a key. The key is nothing but the URL, right? Now, for example, you are storing a file in your machine. You will find out the address, the path of it. Similarly, in S3, that is called as a key, the location where exactly you store. Now, technically, it's very simple to understand, right? You're storing it within the bucket. So bucket becomes a part of your key, as well as what are the path of it, like how many different folders you have. Let's say folder 1, folder 2, folder 3, and then you have an object. So your path is going to be very simple. Your bucket name / folder 1 / folder 2 / folder 3 / object name or the file name. Similarly is the key. Like if you see this example, you have a prefix, you have an object name. Now, technically, if you see the color code, this is the prefix. Like folder 1, folder 2, or another folder becomes your prefix, and object name is the file name, which is my file underscore txt, right? So that's how exactly this how works. Again, don't get confused. If you see my key location here, the bucket name is not having underscore. The bucket name only supports prefix, hyphen. But if you see my folder name or my file name, the folder name or the object name, which is prefix and object name, can support underscore. So don't get confused around it. there is the naming convention or the guidance what you have studied is only limited to the bucket, not within the folder which you define within that bucket. You have complete flexibility to define the folder, even the lowercase, uppercase folder you can define it. So keep that point. And when it comes to the object, so object consists of multiple things. Like technically it is exact the same what you can also see when you get more info of any object. Like you have the key, the value. The key is nothing but the key and the value kind of like it's stored in a JSON kind of thing. Like you have a key, it may be simple as name of the object, location of the object, metadata. Like metadata again we'll understand in the below point, but metadata which is are two types. One, system generated, like generated by AWS itself. One, user generated. You also have the permission to tag your own file which you upload to S3 based on your business requirement, or if you want to isolate it. Similarly, Amazon also generates or automatically by default tags it. And version ID. Version ID you will see in the specific object if you have enabled the versioning on that bucket. Just in case if the versioning is not enabled, then you will see that as a null, which we will understand when we are doing a demo around it. And last, around the access control information, which is around what should be public, what should be private, right? All what you have in generally, if you do read, write kind of stuff, right? What access privilege you have, if you have worked on Linux and all, when you give a change mode and other stuff, right? Similarly, there's access information also is a part of the metadata, what S3 also have, all S3 have for each and every object. So that's about how exactly the S3 includes what additional information outside the actual data of the object. And as we mentioned about that, S3 allows two kinds of metadata, the system metadata, like things like version ID is there, or when it was uploaded, by whom it was uploaded, the location of it. Those are more like a system metadata, which Amazon itself tags it for any object uploads to S3. Similarly, user-defined metadata, which you tag it for your business requirement. So as simple, if I talk about an example for it, you want to by default filter all the objects. So let's say, for example, you have 10,000 different images stored under one folder. You want to only list the images of a flower. So when you, one option can be that you download everything and then you parse it and filter it by the name or something. The another simpler option can be that you filter it based on the tags. That okay, when you are retrieving the object, you specify that if given a tag of the object is, let's say, flower, then only you do it. And when you're uploading that object, that time itself you define that, okay, this image is of flower. Let's say this image is of animal. This image is of location. So when you're retrieving it, you only say Amazon S3 that, okay, give me all the images which are tagged as flower. So that's another way you can use the user-defined metadata. One important point to note here is you can only assign the metadata when you're uploading the object. Once the object is already uploaded, you cannot do it. Now, again, that doesn't mean that you cannot download the object again and you upload it with the revised metadata. That's possible. But there is no API available that without downloading the object, you can change the metadata on the fly. That's not possible. And the last, which we understood, is each object can be up to 5 terabytes. So technically that doesn't mean that you can only store the total size of data in S3 can be of 5 terabytes. No, one single, let's say if I talk about one single file, that cannot be more than 5 terabytes. Again, it will be, there is no such use case outside backup, which I can think of, where one single file can be of 5 terabytes. Again, in backup also, technically you have different incremental backup. So it cannot be one single backup, which is of 5 terabytes. And if it is, then you have to chunk it down based on maybe, let's say, year wise or duration wise. But one single file cannot be more than 5 terabytes, but you can have many such, like thousands of different files, which can be of 5 terabytes. So that's why S3 is unlimited, but one single object can be of, max can be of 5 terabytes. So now I'll quickly cover about the versioning also. So versioning is simple as the name suggests, creating multiple replicas of the same object. So I assume that everyone on this call would know something like GitHub, code repository, how you can take the backup of the code and all. Similarly is the concept of versioning, that whatever data you store in S3, you can version it, like version V1, V2, V3, V4, right? Similar is the kind of versioning you can do for each and every object which you store in S3. Again, couple of things you need to remember is, Versioning will only take care of the objects, or it will only version the objects which are uploaded after you enable the versioning. I mean, I'll try to demonstrate that particular piece, but what it means is, let's say you have a particular object which is already there in bucket. After that, you enable the versioning. So technically speaking, versioning will not be apply on the object which is already there by default. It will be applied on all the objects after you upload it, once the versioning was enabled, right? So do remember that stuff. And you can easily distinguish which object is versioned versus which not with the help of version ID. So if we go back 2 slides, you see that S3 also stores a kind of a system metadata as version ID. That version ID will help us to identify not only between different versions of object, but also in a simple comparison that which object is version versus not. And then there are obviously there are two kinds of versioning which are there. One is cross region, like you can back up your data from, let's say, Mumbai to, let's say, US, or within the same region. So CRR and SRR, cross region replication, same region replication. That's exact the same around it, right? And in order to do the replication also, the important thing is that you need to have the versioning enabled. For cross-region replication, versioning is the prerequisite. If you don't have versioning enabled, then cross-region replication won't work around it. So that's about versioning what you have, right? Before we go around and understand around the replication part, I think I've already covered about the cross-region and the same region replication. Let me quickly jump to the AWS console. So this is the AWS console what we have, right? If someone is pretty new, what I'll do is, let's say you can directly go and type any of these services what you need, not just S3. You can type EC2 or anything what you want to do from the search bar. Then click on S3. Okay, so this is, if I close this, this is all the different buckets. Within this buckets, if I, let's say, create a, let's say I open this one. So within this bucket, this is nothing but as called as a prefix. Technically, you can call it as a prefix, or to understand it simpler, you can call as a folder. Here also you can see this is typed as folder, but this is more prefix. And now this is the object. This object is nothing but what we understood is the file. Now, if I click on this, you can see the different details here. So these are all the system generated metadata what you can think of. And this is my URI or the location, where this is my bucket name, this is my prefix, and this is my object name. Okay, so do remember that this is how things works. Now here I haven't enabled versioning around it. We'll do it in another bucket, but here you can see the different functionality what we just understood. Like you can enable the different bucket properties in terms of versioning and all, as well as storage class, which you will learn in upcoming slides. You can enable encryption, and you can assign. See, this is system defined metadata. You can also give your you can add the system defined metadata, as well as you can give your own metadata. Okay, so that's about the stuff. This is around the permission part of it, like permission, who should have the access in what kind of different stuff, like it should be only read or write, or he can do end-to-end anything, that kind of stuff. And the last, the version. Since we don't have versioning enabled, you can see here there is nothing, the version is not enabled. So this is a quick, I would say, glimpse of how exactly the console look like and around it. Let me do a quick demo here. So now what I'll do is bucket name as demo. I'm not sure, but I'm pretty confident someone would have already taken a bucket name as demo. So here what I'm doing is I'm defining the bucket name. As I mentioned initially also, the bucket name should be globally unique, but you will define the bucket on a regional level. So here I'm selecting APS specific, which is Mumbai AP South 1. Then the public setting. By default, as I mentioned initially also, by default, the bucket is always private. That means none of the person outside your account or the members in your account will be able to interact with the bucket. And again, do remember, that's a very best practice that you always understand what kind of data you're storing in S3, how sensitive it is. If it is some sort of a promotion data, let's say the promotion image of this particular session, which is fine. Even if it gets viral over the internet, it's okay because that is meant to be viral. But let's say on another side, you upload your credit card detail. You won't do that, right? I mean, you won't allow anyone else to access that thing. So you need to understand it, what kind of data you're uploading in S3 and how sensitive is that data. And based on that, by default, it's a best practice that you make it enable. That means you block all the public access. Only the person who has the access of this account can use this. Then you can also enable the versioning. I won't do the version enable now. I will enable it later. You can enable the version. You can tag it optionally, and you can enable the encryption around it. So what I'll do is I'll simply go and create the bucket. So as I thought through, bucket with the same name already exists. That means this bucket name is not global. So if I make it, okay, if I'm just giving it demo, cloud practitioner, women in big data, if I just do that and create a bucket, that means this bucket does not exist globally. So that's why I was successfully able to create this bucket. Now here you can see this is my bucket, which is the name is globally unique, defined in AP Mumbai region, and objects, bucket and object not public. What I'll do is you have to go here, click on that bucket name. It's more like a hyperlink thing. Now we will go and try to upload the object around this. So I click on this upload. Here you can see either you can drag and drop or you can add file. So here you can see I'm already having this poster from this our session, which is around my desktop. So I'll upload this. So by default, it took the name, it took the type and the size. And the destination is this particular bucket. You can also explicitly grant, and again, do remember that grant public access and access to other AWS account. So that means by default, even if you're not doing anything, it will be uploaded as private. And once this is done, I will close this and you can look into this. It's already there as a object name, type, last modified, and particularly the details around it. So that's how is this very simple to play around. Now, it doesn't mean that this was a very small image, so that's why it was very fast. Even if you take 1 terabyte, this is as simple of uploading the data into the S3. Now, what we will do is, again, you cannot terminate or delete the versioning. You can only terminate that bucket and all. You can enable the versioning, right? And again, if you would have read a note, the note was pretty simple that any object which already exists before you enable the version will not be part of it. So technically, if you see here, if I click, you can see this toggle button that comes up, right? This is what I was trying to explain you guys, that, okay, this is the version ID as null. That means there is no other version available for this object. So this object was existing before you enable the version. Now, if I try to upload another image, okay, the same image. Let's say I upload this particular image, which is from one of my blog. And if I upload it, okay, so you can see there are two images. One is a JPEG, which we uploaded before the versioning, and the second one is version. Now, if I show it, you can easily identify, right? So this is how you can identify the difference when which object was uploaded before versioning, which is after versioning. And whenever you retrieve the object, this object version ID will change. Like for an example, add a file. So technically there is no change between the object. It's one and the same, but you will see there are two different objects that has come up. This was the original image, the first one what we had, right? From the timestamp, you can see the old one, 32. And this is 33. So this is 5:30 India time, which will be your half an hour late. I mean, so technically this should be 8 hours and 3 minutes at your end. From my end, it's half an hour because it's my local time. But you can see the different version. Now I can do the similar thing. If I upload this image again, which was there before the versioning was enabled. So another version copy created of this. but still the version ID of the previous object still remains the same, which is null. And there's a new version ID which is created out. So this is how you can create multiple such copies, right? It's not just limited one or two. You can do a multiple copies and they are completely different image. They are not the same image. It's not just a delta of changes. It's completely different. This is an advantage that you can use for backup, restore if something got incidentally deleted. That's an advantage part of it. The small disadvantage and negative part of it, you need to be more cautious about the pricing. Let's say, for example, these are the small KBs, right? It's just 300 KB roughly and 63 KB. If you let's have 5 GB of file, and if you keep versioning it every time, you are not just paying for the cost of the only latest version. You are paying for the cost of the total version what you have. So technically, let's say you have 10 different versions of same object and each object is of 5 GB. So the billing is going to be for the 50 GB, not for 5 GB. So that's why you have to be very sure about it. If object name, so there's a question in the chat, if the object name same, then versioning will show. Exactly, that's correct. That's correct. That's how it's going to be, right? If you change the object name, then technically there's no identity around it. So, I mean, size and all those things makes almost similar, right? You can have 3 objects of similar size. So it directly depends on the name around it. So that's the correct one. But do remember it that from a billing perspective, you need to be very cautious when the versioning is enabled, that you delete the old archival copies which are not required. So this way the billing is only being charged for the limited stuff, not from the old around it, right? So that's about how exactly things work when it comes to how to create a bucket, how to upload the object, the naming of the bucket, the different permissions, as well as the versioning part of it, right? And the difference about how to play around with the version ID and all. So this, what we have understood so far. Okay, that's a good question. What happens when I suspend it and then upload it? That's a good question. Let me demonstrate that. So basically, this is exactly what we have enabled. So it's going to say, if we read here, right, the bucket functionality below are impacted by this change. Lifecycle rules for previous object will still apply. Existing object in your bucket do not change. Newly update with the same name as an existing object, replace the existing one. This is the more important thing. So that simple means if I save this and if I show versioning, so now this version will not get deleted. This will remain as is. This copy what we have created will remain as is. And if I upload a new, let's say for an example, this is my wallpaper of my laptop. If I upload this new image here, and if I go into versioning, you will see version ID as null. This is a file which I uploaded. Okay, so it's similar reverse of what we have understood when we didn't enable the versioning at the beginning. So when we didn't enable the versioning at the beginning, the version ID was null. And after we enabled it, you start seeing the version ID. Similarly, once you suspend the versioning in the bucket, the existing object which you have versioned, which will remain same as it is, or any rules which you have defined on that, we'll understand in upcoming slide what are the different rules, will remain as is. But the new object which you upload after suspending the version will work in a very normal mode without versioning. So do remember that versioning cannot be deleted. Versioning is suspended on the bucket level. So those are the couple of things in detail when it comes to the versioning. Now let's understand. So I think as I mentioned in the previous slide also, versioning is very important when you talk about the cross-region replication. Replication is simple as backup, right? In simple words, what we say is backup. You take, you already have defined kind of a file in one object, one bucket, and it's very confidential and very sensitive. So you back it up in some other places. Sorry, there's a question. Okay, 1 second. So I was here. This is the file which was there, which is a null, right? I will upload it again. Okay. So here you can see the timestamp just got updated with the latest one, but there is no new version created because the versioning is suspended. And you can easily identify it The version will be created if you see the version ID around it. So it got suspended. That's why you don't see the new version around it. Hope that clears your doubt around the versioning part of it, right? Now moving towards the replication. The replication in simple is more like a backup kind of thing, that you have a backup around how exactly you take a backup of your sensitive data. Now that backup can be of two places. Generally, this exact the same concept lies in your old school way also doing it, right? You have a very important file or a presentation, or let's say your certificates and all. You create a copy, you Xerox it and create it multiple places, right? Maybe you create two original copies and save it some other places. Similar is the concept that you have some very important object, financial reports or those kinds of sensitive data, which you can take a backup or you can replicate it across the bucket within the same region or a bucket within another region. Now that doesn't mean that bucket needs to be in the same account. It can be in a different account also. So for example, what I mean is, if I elaborate it, I have a bucket demo1 in account A. I have a bucket demo2 in account B. Let's say if they both belongs to Mumbai, then also it's going to work. If one belongs to Mumbai, second belongs to US and in different account, that will also work. It doesn't mean that it needs to be in the same account. It can be in a different account, and there are two types of it: within the region, across the region. So do remember that. Please don't get confused around it. And at the last, it's not very real time. So when you do a copy synchronously, it's not very real time. It will take some bit of delay around it to replicate. So it's not very like, okay, I just upload a new object and a very near real time, it's just going to go, right? Based on the size of the object. Now, if I do like a very small 5 KB or 63 KB, you will see exact near real time. You upload the object and it's there in another bucket, the destination bucket, right? This bucket. But this also depends on how large is the object. If you upload, let's say some GB, 5 GB, 10 GB or terabyte, it's not going to be immediate. You will exactly face some sort of a delay there because it's asynchronous in nature. It's not synchronous. So do remember that part of it. So don't try to build a solution, any, I would say, application which works from the replicated destination bucket. It always needs to be from the source bucket itself as far as possible. If it is a time sensitive kind of an application, if it is just from a compliance or backup perspective, then that's fine. And different use cases I mentioned, cross region can be, you can have compliance, lower latency kind of stuff, right? Lower latency in terms of, let's say you have different customer across globe. So you can have like a cross region replication for all those customers, right? So they can access the data region close to them. That's kinds of stuff. Simple, I mean, same region replication can be like a log aggregation, or you can see like kind of an, a good example can be replicating the data across the environment. So generally, most of the customer do have dev, UAT, and prod in one account. Maybe they are at early stage or the kind of nature of application. So instead of manually copying that data every time, you can have a simple region, same region replication, where by default the production data, which is if from a business application perspective, can be replicated across different environments. So that's about replication. I think we also cover up the encryption. When I was uploading the object, I walk you through that you can do the encryption, but I just want to get you more details around the encryption part of it. When it comes to encryption, technically, remember this flow chart here. There are two types of encryption what you can have. First, on a very broader concept, in-flight, at rest. In-flight, people also call, or in the industry it is referred as in-transit. S3 encryption in transit, S3 encryption at rest. In transit means any data which is moving, communicating from one service to another is called as in transit. Any data which is stored, like data stored as S3, stale date, I mean, it's there, it's freeze. Any data which is there in S3, any data which is there in EC2, EC2 volume, EBS, or any data which is in, let's say, database, which is at rest. So there are two types of high level encryptions are available, and that's not just limited to Amazon. That's even in the market or across security. In transit, there are different ways you can do it. You can use HTTPS and those kinds of stuff, right? Or you can use certificates which are generated by some authorities, certificate authorities, CAs, which you can use it. we will focus on the second side, on the right side, which is at rest. At rest also, there are two subcategories what you have. One is the client side, one is the server side. Now, the client side one is very simple. From the name suggests, everything will take place at the client side. You are responsible for encrypting. You are responsible for decrypting. You are responsible for managing the algorithm. And if something goes wrong, let's say you lost the private key for decrypting it, you are responsible for it. So you are responsible whole and soul for everything when it comes to at rest. Whereas on the server side, the responsibilities are delegated between you and the cloud partner, which is Amazon here, right? So if I talk about server side encryption S3, where technically it's like a managed kind of thing, which S3 takes care of it. You just have to enable it. Server side KMS and server side customer. You're also in server side KMS, you use the key management services, which takes care of the keys. And there's a broader other details which are there in KMS. It's a very good service, but I think it's a part of outside the cloud practitioner. But for your understanding, AWS also has a key management service where you can store your keys. That keys either can be provided or generated by AWS itself, or you can upload your own custom key. Do remember that. So you store the keys there, and you can also use that keys which are stored in KMS to encrypt the object of S3. As well as you can also use your own, I would say, custom created keys without KMS. The difference here is, in case of when you use a KMS, you upload, even if let's say, first of all, a customer can create your own keys also and store in a KMS. KMS is responsible for securing it. KMS is responsible for providing it when S3 requests for the key. But in case of the last SSEC, which is completely server-side encryption by customer, you are whole and sole responsible for handling your own key. So now you're responsible for rotating, you're responsible for providing, you're responsible for storing. If something gets compromised, you are responsible for it. When it comes to building the algorithm, encrypting it, decrypting, the actual process is taken care by AWS. So don't get confused. There is too much flexibility is provided in case of encryption. Always follow this simple chart that will help you to get very good understanding around it. So this how exactly what I've explained you is narrated in the diagram. That in case of SSC S3, you are not worrying about anything. You just upload your data and Amazon will take care. I mean, S3 service will take care of everything. In case of KMS, is as simple, but you have to define the keys in KMS, and S3 automatically will take care of KMS, and KMS will take care of encrypting around it. Then falls into the customer or the client side, right? The customer keys. There, as I mentioned initially also, that you are responsible for providing your own keys. So you're not, you're responsible for generating, for storing, for rotating or maintaining your own keys, and you provide with the object when you're uploading it. And at the last, as another simpler one, right? You take care of everything, just already encrypted and upload that object in a form of an encryption. S3 doesn't even need to know which algorithm are you using. Are you using some custom algorithm or industry standard? You are whole and sole responsible for end-to-end, for encrypting, decrypting the stuff. It's, based on the industry, based on the kind of business application, you can select anyone around it. But if your regulatory requirement is not to the very extreme level, then I would always insist you select first or the second, because that will minimize the overhead of managing the keys and doing a different operational activity around it. Okay. So that's about the encryption, which is very, again, important, not only from a cloud practitioner, but even for the other certificates which are there, other certificates or when you work in and out in the industry. Now let's come to the access policies or the permission. So we understood around the encryption part of it, or also if you remember when I was just talking to you about the bucket by default is a private, it doesn't allow public. So then there exactly comes as a bucket policy. So bucket policy is like a JSON, which is given on the right side, right? This is exact similar kind of, if someone is already having some exposure on AWS, IAM policy is what defined. This is kind of a bucket policy. I'll show you live on the console. So bucket policy is an over and above which help you to either apply or deny any sorts of an API. Like for a very simple, you can apply a bucket policy on a bucket level that any object within any folder are you cannot allow any, let's say, particular user group to download that thing. They can only read. Let's say, for example, you have two kinds of user group. One is external user, one is internal. Now you created a bucket and you store a couple of images and you just want everyone, I mean, external user to only read that object, whereas your internal user can do anything. Now, so with help of your bucket policy, you can apply that permission on the bucket level, right? That, okay, what action that particular principal can perform on which resource. So since it is bucket, it will be full bucket, the kind of action, get, put, or what multi-part upload, those kinds of different action they can do on which principal. So that's how different kinds of security you can do on a bucket level itself. The very important thing where people use, and it's, I would say, even important from your exam perspective also, is S3 website. So S3, we so far had an image. I think I've been talking about S3 for almost like from 45 minutes to 50 minutes. The image in your head would be very clear that, okay, no, S3 is meant for storage. It provides storage, it provides security, encryption, access policies, lots of other stuff, but it's only meant for storage. That's correct. But out of the way, S3 also provides the capability to create static pages on, as like you can host your static pages on S3 as in form of a website. So let's say, generally speaking, you have your company website, or let's say you have some college event website, which is very static, right? Just like a landing page, you want to talk about it. That you can store in S3. The advantage of doing that is it's completely serverless. You don't need to have any sorts of server. You don't need to worry about the scalability. You don't need to worry about how exactly the requirement or the security is. I mean, security wise, it's very well integrated, which you will learn in upcoming slide. But how exactly things works when it comes to reaching the latency perspective, everything is being taken care by the S3 side of it. You are solely responsible for uploading the object, designing your website, applying more security, and a kind of a domain on top of it with the right bucket policy. So you have to only do these 4 things. Rest, hosting, scalability, maintaining, will be taken care by the S3 itself. That's why S3, I mean, most of the people, you will see they also try, if there is a very simple static UI, they will always host in S3, like the blogs what people generally write, or the resumes or portfolio. These are the couple of examples where people highly rely on S3. Now, the best part of also when it comes to S3 website is you can see this URL, right? It gives you the exact URL like how you have in any other websites. And then on top of that URL, you can also map a domain name, Route 53. We will understand in upcoming slides what is upcoming lectures, what is Route 53. For now, you can simply think of, you get a domain from GoDaddy, right? And then you have a website like Amazon.in. So Amazon.in is a DNS, a domain. Similarly, you can map a friendly domain on the website, which is hosted on S3. So behind the scene, no one can really identify that this website underneath is been hosted on S3. They will always think that it's hosted on some professional platform or on servers or ECS, right? Based on how it scales. But those are the quick advantage in terms of the cost, in terms of the overhead, where people always rely on S3 for static website. Now let me switch to the console. Okay, so this is my simple bucket. By far, you know how to create the bucket, how to upload the object. So I'm skipping that part. I've uploaded a very simple HTML file. This is an kind of a walkthrough I want to do for the static website or the S3 hosting. So I've uploaded around it. Next you need to go is you have to go to the properties. Under property, if you scroll down at the last, you will see that you have to go. I mean, this is already enabled, but if you most of the cases by default it's not enabled, so you have to enable it. It will be disabled. You have to enable this. As soon as you enable it, they will ask you what kind of hosting it is. Do you want to host a static website or you just want to redirect? So generally speaking, many people also redirect, right? That you get hit on one URL, they move it from, let's say, one URL to another URL. So that redirect routing also you can do in S3. You provide which is your main page, which is your error page. And if you want to have redirection, you can also provide the redirection, which is optional. and you save the changes. So there are three things. I will repeat what you need to enable. I mean, for sure, you need your code. Outside your code, you need three things. One, you need to enable this static website hosting. Two, you need to provide the permission. So here you can see I've provided a specific bucket policy of public read, right? That's two. Three, you need to ensure your bucket is public. So when I created this bucket, similar like our demo, I've enabled block all public access, which is on, right? So if I try to access the static website, I'll copy this URL. Right, once. So here you can see it was not properly saved. You can automatically see when I disable the public block access by default, you can see that you get a 403. This is a very common error. Whenever you get a 403 forbidden error, always check the permission part of it. So permission, if I go here in the static, in this particular hosting context, either you haven't made your bucket as public and all the objects as public, or the permission which you have provided in the bucket policy is not correct as per what's required. These are the only two reasons when you can get 403. So what I'll do is I'll try to resolve this. I'll make it disable this. So that means my bucket policy will come into apply. So by default, as I disabled this, you can see the access is public. And now when I will refresh this page, you can see it works. This is a simple page which you got into this. So this is how the static website will work. And again, if you try to ping this, if I give this URL in the chat, this will also work at your end, not just mine. So this is, I mean, I've just created a very simple one-liner HTML page, but this becomes your website around it. And you can take this URL and you can map this URL, the URL what you have, as you can map it under Route 53. So that's how it works. Only one more thing, some can cross question me that generally you mentioned the website needs to be HTTPS, but this is HTTP. So you can also have CloudFront, which is like an caching CDN solution. We'll learn in upcoming session what is CloudFront. Just remember for now, you can have CloudFront also on top of the bucket, which can provide you more security, more restriction, and can give you HTTPS, and that CloudFront DNS or the domain name, what you get, CNAME, that is what you can also put in the Route 53. So that may not only give you the HTTPS, it will also make your website more secured around it. So that's about how to store the website around it. Also do ensure, if you go back and check my website, this is my bucket name up to code. This is my S3 website, which is a static or the fixed key. This is my region, and this is again the fixed key. So if you map this here, this is the bucket name. This is my website. This is the region, and this is the fixed set. The only difference, I mean, most of the people will get confused here. What's the difference here? The difference is this is called as a dotted annotation, where you will see there is between all the segregation, they're split by a dot. Bucket name dot S3 website dot region dot Amazon AWS.com. Whereas if you see in the above notation, there is a hyphen between S3 website hyphen region. So there's a small, thin, narrow gap, but both are the valid format. So don't get confused in your exam. Both are the valid format. It's just that this is called as a dotted annotation way of representing, and this is hyphen. And again, if you get a 403 forbidden error, make sure that you check the bucket policy and allow public read. Cross is, I would say, more from an awareness perspective. Cross origin request. Let's say you request something to one particular domain, which routes the traffic to another domain. Then you can get a cross error, right? So generally, we saw that when we are enabling the static website on S3, and there was something called as redirect. So by default, I'm trying to access, let's say, Amazon.in. Amazon.in redirects the traffic to Amazon.com. So that is called as cross. Technically, it's the same thing, Amazon.in, Amazon.com, but there's a difference between .in and .com. That's a cross origin request. I am requesting to someone else is routing me to someone else. So in that case, you need to apply the cross policy, and cross policy will specifically all the origins, because what happens is when you request, it's always the communication is bidirectional. I request for something and I attach my domain or my IP addresses. The other side on the destination checks the IP address and gets its own name as an origin. So when I'm receiving a payload, I will always receive with an expectation. I will get a payload from the website which I've requested. When I get a payload from another website, which I don't even have requested, then I'll start getting a cross issue. So you have to ensure that the origin of the request is a star. That means I have allowed every domain around it. So do ensure it, and a couple of patterns which you can see how you can get the cross issues. You can get it on different domain. As I mentioned, example.com to amazondomain.com, right? That's one way. Subdomain. Maybe let's say you hit amazon.in only, but the request you're getting is api.amazon.in. The third is the port level. And the fourth is a protocol level, right? Most of the people, even what they do is they redirect the protocol. Like if someone is trying to come with HTTP, you make it HTTPS or vice versa. So these are the 4 ways you will generally get cross error if you try to play around across these 4 things. Always do remember, if you get any cross error, you have to change the origin in the settings as star, which means you allow all the patterns there. I'll quickly move on to the pre-sign URL. When it comes to the pre-sign URL, let's say for an example, you want to generate for now, I made a kind of a bucket as public and I given access. But if you want to give a temporary access to anyone, let's say for an example, you want to allow someone to download a particular jar file or a exe for 30 minutes, and you don't want to open your AWS account, then you can generate a pre-authenticated or pre-signed, means pre-authenticated URL with a fixed time set. And you can allow the user to, with that pre-signed URL, either to upload or to download the object around it. This can be done with help of a flag where you can see -- expires in. This can be for both the ways. When you're uploading the object, when you're downloading the object, you can provide this flag. If you don't provide, then it's going to be 3600 seconds. You don't need to worry a lot about the number in here, but do remember, pre-signed URL is a mechanism via which user can upload or download the object, which is signed URL for a limited time frame. And again, technically generating a pre-signed URL for download, you can easily do it via CLI, very simple of it. But for upload, it's very hard and you can only do it with SDK. So that technically means this functionality, you cannot do it with console. So if you go in AWS console in S3 and you start looking around how to generate pre-signed URL, you won't get that luxury there. You can only do it via CLI, which is command line interface, when it comes to generating the pre-signed to download. And if you want to upload, then you can only do it with the SDK like JavaScript. If I talk about Node.js, Python, Java, Ruby, Golang, with those kinds of SDKs only you can generate the pre-signed URL for the upload. Moving towards the next is a storage class. Now, when it comes to the storage class, right? So these are the different storage class what you have based on the business use case. I'll quickly run through it. I've given a kind of a detail here. Again, this is more like you guys have to just, this is a very vast topic. We can even go like 45 minutes very deep to it. But from this particular certification perspective, I would say you just need to understand there are different storage classes are provided. Again, as I mentioned initially also, S3 is very cheap, right? Yes, S3 is very cheap. If you go for very large data set, when you have GBs and terabytes of data, it's very important that you flush the old data based on your business use case, or the the way you can access that data. Let's say someone stores 100 GB of 10 file, and they are going to only use once in a year. So based on that kind of business use case, you select how exactly you want to store that data around it, right? If you don't know, like for example, starting from the left top, right? The first row. If you don't even know how exactly that object can be, if it virals, it can go crazy. If it is not, it maybe it's okay. Then you can use intelligent, where you cannot predict anything. By default, based on your access pattern, AWS will take care of it. Standard is, and again, one thing I missed to call out is the difference between the storage class is two perspective. The advantage is, if you, based on your right business use case, you can save some costs around it of data storage. Drawback is, if you don't select the right storage, your performance will get degraded. Let's say, for example, you need a very faster response. Like once someone click a URL, you need to download it in like fraction of a second. And if you store it in some other format, the performance of your application will completely go down. You might save some money, but your performance and your end user expectation will be completely different. So do remember two things about storage class when you are looking around it. S3 intelligent, as I mentioned, if you don't know how people are going to react or use that particular data stored in S3, then you can go intelligent. Based on the access pattern, it will automatically take the call. Standard is like everything full. It's a by default, I would say, is provided by standard. The cost is higher compared to all the pattern, but the performance is also very good in standard. Then the infrequent. So as I was talking about, now you have very frequent data, like something like an very viral image, which you store in infrequent. The drawback is the performance which you get from infrequent is very poor compared to what you can get from standard, intelligent and non-standard. Similarly, you have the different kinds of stuff. You can have glacier, and glacier. These three things is for the archival. Whenever you see a word called as glacier, do understand this is more meant for archival purpose. And then there are different terms are there: instant retrieval, flexible retrieval, deep archive. The cost is also on same lines. The cost of a glacier is higher. If I compare these three, the cost of this is higher compared to this, and this is the most cheapest. The difference between three is all three are going to archive your object in a glacier. But whenever you request glacier that give me the object, based on how faster they can give the object, they are most costly. Like if you archive an object and whenever you request, you need immediately, like within like 30 minutes or 1 hour, then you will go with instance retrieval. The cost will be of that higher. Flexible is you can do it at your own stuff within the period. Then that becomes a flexible. Deep is, okay, you storing it at a very cheap cost and the retrieval can be in hours, right? So you can see this. This is in milliseconds, the retrieval. This is from minutes to hours, and this can be above hours, right? So based on the kind of access, based on the kind of your pattern, you can think around it. And then one zone. So as I mentioned, S3 is highly scalable, but you can also be sure that, okay, let's say there are a couple of images which are not very important. You just need it as a backup. So you can store it as a one zone. So just in case if something goes wrong, that subnet, that particular subnet, that zone is down, or something goes wrong, still you can recover that. Or if it's not available for particular hours, that is also fine. Then you can go with one zone. And as the last is S3 on the outpost environment to meet the local data processing and data residency need. Anything which you need like an on-prem side of it, you can use S3 outpost. So these are the different storage class what we have. Again, no one can remember this different charts, but if someone wants to really go depth and understand very in detail, because this is very important when you're doing the FinOps kind of stuff, like when you're doing the financial operational for the cloud, the small things will help you to save the cost. You can go through these charts and these numbers in detail, which will help you, given this use case, how we can work around it. This is, I've got it from VMware company, where they have given the best, a kind of a decision tree, given in scenario, how exactly you can decide which of these storage class should work. Why so, right? This is very good flowchart. I've never seen that. This is very good and will help you real time. You take your example and this will help you to conclude how exact or what kind of storage you need based on your business use case. So you can take any example and you can run through this. This exact what I've mentioned in the storage class, you will see the narration is same, but this is very stepwise oriented approach you will see here. Now comes to the important point, right? So we saw this point even when we were working on the replication, when we were doing versioning, right? So when we were suspending the version, you saw one note, very important note there, that any rules which are already applied, the life cycle rules, which is already applied will not be affected. Now, no one asked me that question, but exactly what is the life cycle rule? Technically, let's say there are many requirements that comes up. I upload a data to S3 bucket. First 30 days, I mean, there's a business requirement that people will only use that data for first 30 days. After that data, after that, the data needs to be there in S3 from a compliance or governance perspective, but no one is going to use it. Someone, if auditing comes, then they might need like within 5-6 hours. So how I can achieve that problem statement, right? Because I've uploaded the object as a standard because I need for 30 days, but after 30 days, I don't know. Maybe it can even go to Glacier or Glacier instance, right? So that is called as life cycle, that you can define the rules. Whenever you upload the object, you can define the rules that, okay, this file after 30 days or on 31st day, you can move it to, let's say, Glacier, or you can move it to anything. So this is how the flow works, right? From standard, you can go to any flow directly. The reverse is not possible. Like from deep archive, you cannot come to the standard, but reverse, from top to bottom, it's possible. So this is called as a life cycle rule, which you define the transition of the object across different storage class. This is a very complicated one, like how exactly you can move, but the simple narration you can see on the right side. So that means if you have a specific business requirement, you can go ahead with the costly version, but over a period of time, when you realize that that object is no more required, you can move it across the optimized storage class. The last topic is the performance perspective, right? From an S3, the performance, as I mentioned, you can upload a file up to 5 terabytes. Technically speaking, if you even try to upload a 5 GB file from a UI console, you will receive some sort of an internet glitch at your end, which will break the upload. So how exactly you can come up with such kinds of scenario? Or let's say you are sitting outside, let's say APAC. For an example, I'm based out of Mumbai. I want to upload a file into a North Virginia region. Some MBs, KB file will work flawlessly fine, but I want to upload a 5 GB file. So you can understand the kind of network latency that will come up. So those are the two options which are available by S3: multi-part upload. Highly recommended by AWS that whenever you have any object which is more than 100 MB, you use multi-part upload, where AWS takes care of that chunking that file and uploading in S3 in parallel, right? To speed up your entire transfer, sorry. That is called as multi-part upload. And the second one on the right-hand side is S3 transfer acceleration. So in case, if you remember, I mentioned around the edge location in last section. Edge location is like a caching. That, for an example, when you're watching any video, do you always feel it's going to go to the server and get a video for you? No, right? If it's a viral video, someone in your locality will already be watching that. And from that common cache, which is within your area, the request will be served. It always don't go to the actual server. So that works as called as an edge location from the cache where the cache server is located. Similarly, how it works is in transfer, let's say I'm based out of Mumbai. There will be multiple such location in Mumbai where there will be cache server. So when I want to transfer any file to North Virginia, if you see this particular step, there are two approaches. Either I can upload it by a normal upload and do it. It may work for a couple of KBs, MB, or even like few GB, but not for 100 or 200 GB. So what I do is I do a more optimized approach. As an user, I use transfer accelerated and upload to CloudFront edge location, which is very local to me in my area, so that the traffic will be faster. I can easily do it. Post that, the CloudFront uploads the file in the required S3 bucket, which can be any part, anywhere in the world. So that's how I can do it in a faster way with help of S3 transfer acceleration. I can upload any size of object in a very fast span. So that's how we can increase the performance about multi-part and the transfer accelerator. Two more things when it comes to about S3 is the how exactly the S3 select and the Glacier. Now, most of the people would already be using something called as Google Drive. If you want to, you have uploaded a file, a CSV or an Excel file in Google Drive. What you're going to do, Either you will download that file or you will open that file with Excel and you will read the content. In S3, there is a mechanism called as S3 select and Athena. Athena will be in upcoming slide. Without downloading the file, you can read the content of the file with a simple SQL, right? You can fire the query like where condition, those kinds of simple kind of SQL what we have, right? Select star, blah, 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 limit row number equal to this. Those kinds of stuff, you can easily do it without downloading the actual file. Less network transfer cost and less CPU cost to the client side, right? Instead of downloading, let's say, entire file itself locally, retrieving it, understanding it, analyzing it, you can directly do it on the S3 select itself. We will understand it, how exactly that works. And the advanced version is the Athena. Athena is not kind of an S3 select. It's used for more complex analytical use case, right? Let's say you have a folder. Within that folder, you have different thousands of log files. You want to run the query across all those different 1,000 log files and want to extract the traffic which got originated from one particular IP address, which is called as log. I mean, in this use case is called as log analytics. You can easily do it with Athena. Athena is more serverless. You can, I mean, many people refer as a serverless warehouse, or it's a serverless query system which works on a Presto. So Athena underneath has a engine called as Presto, which is more suitable for a Parquet format, which is a different kind of data format what you can have. And you can run the data which is stored in S3. With help of Lambda, you can run the queries and extract the data across different sources also, or even on-prem. So that's the best part of Athena. Again, best thing is not its capability of querying across all the sources, but also the pricing. If you see the price factor of this, the price is $5 per terabyte of data. And again, you know, there are multiple ways. You can compress the data, you can zip it. That's why you can also reduce the size of that thing. And it's purely on the what data you scan, nothing on compute front you're paying around it. That's a wow factor of Athena. And you will see most of the analytics solution, any analytics solution which is there on webinar by AWS or any other clients, most of the 90% of the solution do have Athena that gives them the capability to do queries on an ad hoc basis without really worrying about the compute and any stuff. So that's about comes into Athena. And then the best part is you can also, like, let's say you don't have very sophisticated requirement, you're very early stage, want to just understand your data. You can also plug any sorts of visualization, like not just limited to Amazon QuickSight. You can do Power BI. You can do any sorts of BI tool on top of this Athena, and you can extract and work around with that. So that's also you can do around it. So not only just doing an analytic query, but you can also do a BI. You can connect BI on with Athena and just visualize your data also. At the last, one important thing what we understand at the beginning was the event notification. So this is a very good thing when we talk about any serverless application. Most of the people always keep hearing about Lambda, serverless, and all those kinds of stuff. Any serverless design or architect you pick up, it will have something called as event notification. Event notification is you do any action, whether you delete a bucket, whether you create a bucket, delete an object, create an object, rename it, whatever kind of operation you do in S3, there is an action is generated. That action goes to CloudTrail, and from CloudTrail, you can trigger the notification, right? You don't even need to go to that part. By default, within the S3 console itself, whenever there is an action created, you can generate the notification and you can send that notification. You can send that notification to SQS. You can send that notification to SNS or the Lambda. Also, I want to call out one more thing. Recently, this reInvent, Amazon also provide the capability that via S3, you can also send a notification to an event bridge, which is more like an event bus. Via that, you can send the request or you can trigger and do anything, right, across all the services. So not only just limited to SQS, SNS, Lambda, you can also send the events to event bridge and trigger, process, and do whatever stuff of it. Very simple example, which I use or which I've seen people using about event notification is validation, data validation. Let's say there is someone who uploaded the file into S3 bucket. Now, after the file is uploaded, you want to ensure the content of the file is correct or not before you process it. So what happens is you can directly, whenever someone uploads, you can see that the upload event, create new object event is generated. Once you receive this, you can send it to either SQS, SNS, Lambda, or Event Bridge, and you can download that new uploaded file, process, check all the rules, and move it to another bucket via which you can ensure that file is correct, validated before you trigger any downstream or any business application. It's a very common pattern and very common use case, I would say, across industry when it comes to validation of the data. With that, we have covered up the S3. I will take a break of 2 minutes. And if you have any questions, please feel free to put it on the chat. Okay, I see a question. Which file/data type supported by Athena? Okay, that's a very good question. It can support, for now, I can just tell you in shorter, it supports multiple different types of data types, all the basic one, like integer, if you talk about, varchar you talk about, or sorry. So you can talk about integer, varchar, numbers, string, decimals, right? Those are all the basic data types what you have, it supports. Along with that, it also supports JSON, right? You can also have data format as a JSON format also, right? So in whatever you need in technically, I mean, you can have in a normal traditional SQL, it can support all those different types of data type. And again, for sure, I'll pick up a detailed slide, or I mean a detailed document which can help you, like not only just the data type, but even like what varchar to or what size and other stuff. But it supports all of the most widely used data types around it. Why I am not sure than intelligent tiering. Can you please elaborate on your question, Tanvir? Like what exactly are you looking for?
Why I am not why ST standard then ST intelligent pairing. Why I am not sure ST meaning I am not sure ST then you said then I am not sure uploading the object ST I am not sure. I think you understand.
Sorry, I honestly, I think your voice was a bit muffled, so I was not able to hear out clearly. Would you mind pardoning your question, please, again? Hello, can you guys hear me?
Yes. Why I'm meaning meaning ST you said ST standard, then you said ST intelligent tiering. If I'm if the if intelligent tiering, then the object is not sure, meaning I cannot go to ST standard, but only ST intelligent tiering, then we'll go to the other portion of it. Then this is what you said.
So basically, if I hear out your question about intelligent tiering, right? I'm not sure, correct? That's what you're trying to refer?
Yes, yes.
So basically, okay, I will elaborate a bit what I mean with that. Generally speaking, let's say for an example, you have a poster, an image, right? You let's say very simple. You have a poster which you create. Now you don't know whether that poster can be viral or not, right? You, I mean, you always expect that that poster will be, I mean, Or very simple of it, you upload a block on S3. Now, when you upload a block, that doesn't mean that there will be 10,000 people will be reading that block. It may be possible even 10 people read it. Or it may be for your second block, you get 1 lakh people read the block. So that is what we are not sure on the traffic which is going to get. Did I explain to you? Did I answer your question?
Yes, yes.
So since we are not sure about the traffic or the access pattern of that object, there exactly intelligent tiering will help. But again, your question is very valid. Most of the cases, when you talk about any, there are 2 kinds of things what you can do. One is a very fixed defined application where you're pretty sure that this object is going to be read by 10 processes of my platform. Then intelligent may not work for you. You can go with standard and you can take care. But things like when it is open for the actual, all the customers, like globally available for all the customers, that time intelligent tiering makes sense because you don't know how many people are going to hit your URL to either download that image or to read your blog or to do a different activity, right? So there exactly intelligent tiering will help you.
I cannot go to ST standard. So why I don't directly go to ST, then I life cycle it. This is the most preferable way, I think.
Sorry, can you elaborate can you just pardon that last line?
I am not sure. Intelligent tiering to ST standard is not possible. So if I know that if I know the object is accessible to the public, then I can go to ST standard. Then I can life cycle it. Then it is the best way. I think it is. Then it is the best thing.
Okay, so I'll explain you. When it comes to life cycle and how object transition within the life cycle, one of the thing what we have to remember as a thumb rule is when the object moves between the life cycle, when you're going to move the object, when you're getting some sort of a cost saving, correct? When you get some benefits, that at that time only you're going to move the object from one life cycle to one storage class to another. Standard being the very costly. If you look all the kinds of storage class what we have, standard is very costly. Then you have intelligent tiering. And when it comes to even the performance part of it, both are head to head. The performance which you get from standard, it's almost the same what you get from intelligent tiering. That's
Okay,
why
now
if
I understand.
you understood now?
Yes, yes.
So that's why it's not supported that when you go for storage class, you will always look for that. Okay, I try to save my cost. When you're already saving your cost, why you will take a backtrack from it, right? So that's a case around it. But yeah, that's a very good question. So I mean, looking at the time, I will move to the next question, next section, which is compute. Again, just want to, before we start the compute, right? When you talk about AWS compute services, there are different services what we need, right? One second. So when you talk about the compute services, just Amazon EC2 is not the only compute services. There are many services which are available by AWS, like things like Lambda, things like containers, which we'll get to know in all the upcoming sessions, right? But for now, we will be only focusing on EC2 within the compute. So don't get confused anywhere. For this session, we will be only focusing on the compute side of it. In upcoming session, we will talk about the remaining services of the compute like Lambda, serverless, containers and all, which will help you. And again, I will explain you at the last, we will see why exactly I have picked EC2 at the first from the compute. So technically, I mean, most of the cases, how it works is, this is your host computer, which can be your desktop and laptop. And then you have an host OS, your operating system, which can be Windows, Mac, Ubuntu or anything. This is how generally most of the people across any industry, when they work on any laptop or device, this 2 layers they do have. Then there comes up the problem which happens is, right, even though if you have very big server kind of thing, it is just limited to one user. So then it comes up virtualization, virtual box. You have VMware when you can create like a virtual different guest on top of it. That's how it works in an on-prem side of it. Like you have a host computer, host OS, and virtualization software. So this can be as simple as you can think of like any VMware servers or any on-prem application around it, right? This is how you can work. This is how things works at the on-prem side of it. If I move to the next slide, this is exactly how it works when it comes to the cloud part of it. So anything which is in the purple is provided and handled by the client. Anything which is in green is handled by the end user. So immediately you see the difference which is coming out here and here. In case of cloud, the hardware, the virtualization is completely responsible of the cloud partner. You're only responsible for deciding what different type or what power of EC2 you need with what operating system. That's what you need. And if you see the on-prem, you're fully responsible for doing everything from bottom to top. You're not just responsible for handling the host computer, host OS, or virtualization. I mean, you or anyone within your team or within your company, in short, your company is fully responsible for doing it. You're the cloud partner already abstract the hard code part, and you're only doing the simple work. So that's a big difference when it comes about how exactly you can think of any machine, physical machine versus any sorts of virtual machine on the cloud. And this green box is what refers as EC2, where there are different families, right? This virtual server is different kinds of EC2 instance families, which are there, where you select when you launch an EC2 instance, which we'll try to demonstrate today. You will see that you provide different kinds of details around it. I need X kind of server, Y kind of server, and those kinds of capability with this hardware, this kind of memory, that kind of stuff it is. Just remember one basic rule, which I missed to call out in the last session. Whenever you heard a term called as memory, in case of cloud, memory always represents RAM, right? What we refer in an on-prem side of it, RAM, right? Your main memory. In main memory, which we refer in our physical system or on-prem side of it, in cloud, it is called as memory. So don't get confused. When you heard memory in the cloud, that always means RAM. When you heard as a storage, that means hard disk. What storage you need, that means what hard disk you need. What memory you need means what main memory you need. So those are the abbreviations which you have on the cloud side of it. I do generally mention that in my first session, but I think I missed it for this time. And then you have different OS and application on top of it, which varies from your business use case around it. So do remember about the difference in the first slide and the second slide. Again, this is not for any certification and other stuff. This is the foundational basic thing which we should understand. So as I was talking about, right, the virtual server, like this particular segment in the virtual server. So these are exact different instance type provided by AWS. From left to right, you can see general purpose, compute, memory, storage, and accelerated computing. These are the different kinds of family provided by AWS based on the kind of use case you have, based on the kind of requirement you have, right? Like for example, you have very simple application that you need to build around it, you will go with general purpose. If you need very compute heavy, like you're doing some algorithmic work, then you will go for compute. If it is more like big data kind of an application where you need high main memory and those kinds of stuff, it will be memory optimized. Then you have storage. And if you need any machine learning, like graphical GPU based, then you will go into accelerated computing. Just give me 1 minute. I'll just be back in a minute, 1 minute. Okay, so yeah, as we can see from left to right side, based on your requirement and business application use case, this is very important. Again, this is the similar kind of thing what I described in storage class. AWS is helping you to simplify all those kinds of different stuff, right? By just only focusing on business application. As an end user, it is very important for us to wisely understand the different configuration and select the right thing. I've seen many people missing out this calculation and the thought process, right? They will have very heavy compute requirement, but they will directly choose general purpose or memory optimize. So it is very important that what kind of application you have, you understand the need of it, and then you select the kind of an EC2 or the family which you required. If you select the wrong family, it's not going to be problem in terms of the cost, but even the performance. Because how it's going to be help you in the cost? Let's say if you're not getting an idle performance, you will keep increasing the servers, like keep adding more and more memory, which will cost you more. But the problem will be that you have selected the wrong instance type or the wrong family of it. So please always do ensure that increasing the size of the server is not the always solution to a problem. The problem may be different always. So just to understand what exactly is the problem around it, based on your business application use case, select the right instance type. And then if you see the performance is not up to the mark, then you increase or vertically scale to the next level of your instance. So those about the instance family, what we have. Next comes is the security group and key pair. Security group is, in short, if I summarize it in one liner, is like a firewall rules, right? You have firewall rules to ensure that traffic which is going in and out of EC2 is only defined like the same thing which I mentioned in S3 also. Generally, you do not want everyone to get into your EC2 instance and start playing around with it, right? You're paying for the cost of that server. You have some application running on it. So you don't want anyone, like you will not like that I get in your EC2 instance and I start playing around with it, right? So that's how you secure with the firewall rules and with help of key pair. Key pair is more like an identity. So when even you want to get into your server, you provide an identity that, okay, hey, my name is XYZ. Here is my key. Please allow me to get into it. Now, when you launch that server, at that time, you have your key provided there that, okay, this will be my identity. Any person who comes with this particular identity, you allow them. Don't worry, I'll demonstrate you what I'm trying to say. But do remember, key pair is more like it's like a PAM file only. It's like a PAM file, like more like a certificate kind of stuff, which is like your identity, which will allow you to get into the server. And that is not just limited to Linux, it's also applicable to the Windows server. Second is the security group is more like a firewall. This is more on the